So good afternoon to everybody. Luigi, do you hear me? It's
Yes,
fine.
I do.
Yeah. Good afternoon for who lives in Europe, and good morning for who is on America, and good evening for the people in Asia that are
Asia.
following the webinar. So thank you very much for all the attendees, and to participate to the last webinar of our first season. We have in program to explore the possibility to go ahead with the season, especially for webinars, which were the most appreciated one. My name is Damiano Zito. I'm the CEO of ProGold, but today I'm here like just supporting the speaker of this webinar. The formula of the webinar is in two parts. The first part is a PowerPoint presentation, which will take something like 30 to 35 minutes. Then could be also not longer than 40 minutes. And a second part where you can do all the questions. And I hope that the webinar will be able to become a discussion, and in this case it will be also it will be more interesting. Then you can find all the material online, so the video and as well the presentation. The today webinar title is Why Jewelry by Direct Metal 3D Printing. The presenter is Luigi Benetti, which is a first friend of mine and founder of ProGold almost 25 years ago. And from the last 5 years, is managing the business unit of our service bureau of metal printed parts. And so what to say more? So I give you the word, Luigi. So go ahead. So it's your time now.
Okay. Thank you, Damiano, and welcome to everybody to this presentation on direct metal 3D printing. Okay, it should take about 30 minutes. Then we'll, as Damiano told us, we'll handle a period of our question and answer. So let's start. Some clarification before starting on definition. We'll often use SLM, the acronym SLM, that stands for Selective Laser Melting, referring to direct 3D printing in metal, okay? Additive manufacturing technique using high-intensity laser to melt powder and build a solid. We'll also use some other definition, such as traditional casting, using rubber wax injection models, and direct casting using 3D printed wax and resin models. This is the summary of the presentation. We'd like to take your attention on the first picture. It's time to try SLM. We think that SLM, this technology, is now mature and ready to be used, okay? Then there will be an introduction to direct metal 3D printing process, and the central part of the presentation about why and when switch to SLM. At the end of the at the end of the presentation, but anyway, during the presentation, also some comparison among a technical analysis of SLM and also comparison with traditional and direct investment casting. Well, precious metals production processes remain unchanged for a very long time. Then some innovative technologies came on the scene, such as rapid prototyping, CNC, electroforming, laser soldering for sure, and found application on production chain. We think that SLM, in the same way, is a very true innovation and can do the same, okay? So find a real application, an easy application on production chain. We have been active on 3D printing for many years and have deepened some technical topics such as print parameter and strategies, physical and mechanical properties of objects produced by 3D printing or SLM. We tested the alternative material, chemical composition for our powders, and deeply investigated the granulometry of these powders and support projects matter, okay? We also consider everything to achieve the best resolution possible. And this is what we did previously. Today, we want to take a very practical and operative approach to the matter, okay? Together with you. Sorry. This is an animation that shows file management on the computer by our technicians, then printer powder loading, even if it's not an operation that you make every time that you use the printer. And then this is the Realizer SLM50, our main printer, 3D printer. This is the printer powder loading, okay? Not exactly in this way. This is just an animation. This is the powder spreading on the platform, okay, by this mechanical wiper. And then selective laser melting, SLM, this is the acronym. Again, while there is platform lowering, again, there is new powder spreading and selective laser melting, okay, for the progressive creation of the solid that is inside the powder. This is the true melting, okay, of the process. And you see the platform lowering and the creation of the solid inside the powder. This is how the 3D printer works, okay? And then we can see the objects fixed on the platform by their supports, okay? This is just an animation. Now there is a live video, okay, inside the camera is on the inner gas internal chamber, okay, and you can see the laser melting, in this case platinum elements. The laser is working and is melting some connected elements of this platinum bracelet. Then the mechanical wiper spreads a new layer of powder, and again the process of melting by the laser. Okay. This is a very fast production process flow. Okay, we start with the file evaluation and then study the support projects for the growth and the heat dissipation of the parts that we are producing on the platform. Then there is the true 3D printing. Okay, so what you have just seen on the videos. Then we remove the platform, and for supports removal, we take off the platform from the 3D printer. For supports removal, post-treatment, and delivery. Well, now we are in the interesting part of the presentation, why choose SLM? So now we face the reasons to choose SLM. SLM is a fast process, okay? When the file is ready, you print, and the technology does not require preparatory phases of models, molds, production of waxes or resin, casting, tree assembly, and bypassing also the complex matter of the complex material of the complex matter of feeds, okay, of this casting tree, flux preparation, and this allow fast delivery, very fast delivery of samples, one-offs, small batches, and so on. SLM also allows new design. For example, it completely solves undercut limits. It allows to produce empty, closed, and without any further soldering phase objects. And you have to consider that these empty, closed, and without soldering objects can be very large and flashy, okay? As we try to show you in this picture on the left. It allows very thin walls, up to 0.2 millimeters, reducing so the weight of the parts. SLM is particularly suitable to produce platinum and titanium, high melting temperature metals, and it obtains very impressive density for the parts. With the result of defects-free surfaces. Our survey bureau operates with 6 metals so far. So we have got 18-karat gold, 2 color of yellow gold, rose gold, and palladium white gold, together with titanium and platinum. As I told you before, SLM allows to create large whole of objects. The picture here shows a cut, but is just to show the part inside, okay? Only 2 very small holes are required to evacuate powder in the parts. Traditional casting instead requires 2 or more parts assembly and soldering. On the right, direct casting require gates to evacuate investment. Here we have 2 casted rings. Geometries are not particularly suitable for SLM, but help to point out some casting requirements we might overcome with SLM. Here, a ring with assembled internal lining, and a ring with weight reduction empty. Okay, we overcome these limits with SLM, as we can produce parts without any kind of soldering and application of internal lining, and we can avoid emptying, working on the geometry of the part and creating hollow part with very thin wall. This is the soldering line, and we saw that assembly needs soldering. Here we have the soldering line. And this is a real picture, okay, where with a visible soldering line. In case of rose gold, the line is more visible than in other case, and there is also in rose gold and in the other colors a shrinkage due to different surface hardness. Probably in the top of this picture, you can better see what I mean as a shrinkage. High-end jewelry, color trend, okay, and the relation with the soldering troubles that we have just faced. There is this is the trend of the choice in high-end jewelry. So we see that there is the market prefer rose gold for basically for this kind of product. The chart shows how necessary wall thickness increase for traditional and direct casting, okay, and this is the movement when the surface to be obtained increases, okay. SLM instead, that is the red line, can maintain the same wall thickness regardless the surface extension. You can see also that for traditional casting, however, the starting point for wall thickness is already higher in respect of the other shoe due to the limits of rubber injection and was extraction. This is an extended surface titanium 3D printed object, okay? On the left, just a virtual picture. On the right, the real one picture of the part. We were able to produce this part with extended surfaces, maintaining a very low wall thickness. Okay. Regarding the thickness, you know that thin objects require higher injection pressure with the risk of rubber swelling. After resin removal from investment, some residuals may remain and cause incomplete details, okay? On the left, we have the resin, a picture on the center, and the virtual part after casting on the right. These are the residuals, and these are the incomplete details. Thin objects are difficult to be removed from rubber, okay? Notwithstanding with the thickness, in any case, when the parts start to be very, very thin, there are also problems and troubles to remove the resin or the wax from the rubber, and there is the risk of deformation. I think this is a very important and interesting topic. as I told you before, SLM perfectly match with high melting temperature alloys such as platinum and titanium. By casting, both these they both implicate a more complex process, casting process. Okay, and as you know, both they require specific plants that often are not fully exploited. And this is the reason why we push on platinum and titanium toward SLM. Platinum is probably the best metal, the best material, okay, the best performing material with SLM. And regarding titanium, you probably know that it's very difficult to cast material with a large number of scraps. Conversely, you get very impressive results with SLM with both these materials. Okay, this is just to remember that SLM is a melting process, and here we show a grain size benchmark, okay, among 3D print SLM, I would say, metal direct 3D printing, traditional casting, and casting. So remember that SLM is a melting process, and here on the top of this picture, you might see the size, the grain size, okay. While on the bottom of this picture, there are other lines, but they refer to the production process. This is not the grain. On the top of this picture, there is the grain. Well, better here, we have a larger image. This is the grain size of SLM. These are approximate resolution values, dots per inch, on XY axis and Z axis, okay, of printed parts. Z is the growth axis of the parts on the platform, and the higher resolution compared to X and Y depends on the very thin powder layers. This is a specific sample. Yes, a specific geometry that we've 3D printed to measure dimensional coherence. In fact, the chart shows results, and you can see that SLM, this triangle, red triangle, is very close to the nominal value. I think this is a very important matter. I often underline that there is a very impressive dimensional coherence of the 3D printed parts. Okay, here you can see the same ring, even if they could appear different, but they are the same geometries in these pictures. And we want to show that SLM support projects and casting feeder surface, well, SLM surface of contacts among the supports and the part is lower than the surface of contact among the casting the feeder and the part, okay? This is the aim of this picture, to show you that the surface contact is lower in SLM. Here we have an example of quite heavy supported part and a light supported part. This is the same geometry, and we tested a more invasive supports and a less invasive support project. This is the difference that appear on the parts themselves. Printable or castable. Everything starts with the evaluating a potential DU file suitable for SLM or for casting. For example, here on the left, you see a part that we do not think suitable for 3D printing, and on the right, a part that we judge suitable for 3D printing, for SLM, and probably a little bit difficult for casting. And this is the reason. Supports are difficult to be removed in this case, and are in a very tough position to be removed and to be polished, okay, to allow polishing of the part. In this case, instead, we think that the feeder system to cast this part is quite large and important. We have got another example of SLM not suitable geometry. This ring, the traditional 360 degrees ring, simple ring with stones. Okay, and on the left, a part that we judge very suitable for 3D printing and probably difficult to be processed by casting. We are at 28 minutes. Okay. Here we have some different standing of the same geometry on platform. Okay, and these different standings make different supports quantity. You can see here that the different position change. We would say, and we would call it production yield, okay, from weight point of view, because we have different quantity of supports according to the position that we select on the platform of this part. I would like to add in just a very fast remark. I think that in these last 3, 4, 5 years, okay, when we started the service bureau, we were able to develop and to reach a nice know-how regarding the supports projects and the position that parts must have on the platform, aiming to a very impressive final result after 3D printing. Okay, here we have some ring section, casting and SLM, that were embedded and lapped to check surface with the microscope for porosity measurement. I try to show you, okay, the comparison among casting and SLM. Okay. In all previous research works that we did, have always paid particular attention to this matter, that is the incidence of residual porosity. Without reporting here a lot of data, we can decidedly affirm that residual porosity is lower, even 50–60% lower, okay, with the SLM compared to casting. And in fact, here there are some results of software, okay, checking of porosity quantity on the surfaces, as I showed you before. Okay. mechanical properties. Charts. Chart shows UTS values on the left and elongation on the right for SLM and casting objects. The higher SLM values confirm metal higher tenacity, and this is a proof also of what I've just said. That is lower residual porosity. Okay, so this is the proof of what we have already said, and the fact that the metal has got a higher tenacity. Here we have microscope topography of SLM and casting surfaces portions, and this is just to show you that there is not so much difference among direct casting topography and SLM topography. Okay, here wall thickness and volume control. We say that SLM allows to create large and flashy hollow objects. At drawing phase, you can choose the wall thickness that you need and decide, so, volume and weight of your parts. Here an example of same external dimension for these parts and a completely different volume and weight, okay, according to the dimension of wall thickness. By wall thickness, you can also control another thing. In fact, SLM allows you to maintain the same weight when size of your part change. Okay, here we have some different rings, an example of rings from 48 size to 60 size. Okay, you understood that you can change the wall thickness of your parts and maintain the same weight. The charts shows the same thing and the same concept. Okay, gray is solid ring volume and blue is SLM ring volume. Okay, the blue remains the same. The gray volume increases as the weight of the parts, while the red line of SLM remain flat. I show you some internal ribs that you could provide if you need to to assure a structural reinforcement of your parts. Okay, particularly if you use a very thin wall thickness. It's not necessary if you use what is a standard thickness from as 0.35 millimeter is. Okay, probably you don't need to use these internal ribs, but it's possible to do it if you decide to select a very, very thin wall thickness, such as 0.2 millimeters, as we spoke before. And this is the ribs. Okay, production lead time. Charts shows how SLM lower production lead time compared to casting for prototypes, one-offs, and small batches. Okay, you see that the production lead time is lower for SLM. And I spoke of small batches it depends for sure on geometries, on weight of the parts, but basically till small quantities, that is 15 pieces, 20 pieces, something like that, okay, SLM maintains this kind of advantage compared with traditional casting and direct casting. From a sustainability point of view, SLM low and flat carbon footprint. Okay, we can see the low and flat carbon footprint regardless process yield. Okay, while a higher carbon footprint for traditional investment or direct investment casting in case of low process yield. Okay, when later on the process yield increases a little bit, also they this value goes through a drop, okay? Well, this is a radar chart to show the performances, to show a comparison, okay, among the performances of traditional casting, direct casting, and SLM. For example, I would like to show you as the performance of SLM regarding defects, for example, regarding flexibility of geometries, and also regarding lead time that we have just faced, okay? An high performance regarding lead time, production lead time for one-offs, prototypes, and something like that. Okay, here starts a gallery of pictures, okay, such as platinum. This is not what was working before, but an example of connected elements, already connected elements printed on the platform. You can see that
even a very high resolution.
Yeah.
In this platinum.
Well, correct. I try to magnify the resolution. Okay, I don't know if I'm able, but probably from this kind of magnification, you can see that, as I told you before, platinum is the best performing material among what we are using so far. I mean, okay, so you can note a very high resolution of this part. And in this case also, in this case, I mean, in the case of this geometry, a very low supports requirements, okay? The supports are very, very low for this geometry. I hope to have spent all the necessary words regarding platinum and titanium and how these materials, or better, how SLM is particularly suitable for this material, okay? I hope to be able to spend the necessary words, as I told you, and I'm ready to speak with each of you, okay, regarding this matter, because probably they require a little bit more time, but please focus on your mind platinum and titanium for sure. For sure, 18-karat gold as well, okay, but please focus in your mind platinum and titanium, and feel free to contact me to speak about this matter, because results in platinum, for example, are very, very impressive. Okay, a simple geometry in yellow gold, a particular geometry, rose gold, connected with all the troubles of soldering that we have investigated previously. Okay, so you can see the hollow object, completely hollow object, just to show you, because this is just a choice that we did to be able to show the completely hollow object inside. another platinum geometry, particular geometry, okay, of a connected, already connected bracelet. And probably you can see also in this picture the particular resolution of platinum, of 3D printed platinum. Okay, we reached the end of the presentation, and now probably Damiano will add something.
So,
and it took 41 minutes, so probably we were able to maintain the presentation inside the correct timing. And now we have got time for question and answer that I hope be very numerous.
So thank you very much, Luigi. Before giving the closing of the presentation and starting for the question, so I ask you to put as much question as you can on the question and answer, and we will be very glad to try to answer any doubt you have. So the presentation, as you saw, it was a general trip on why choose selective laser melting to produce your jewelry. So thank you, Luigi, and let's start with the first question. So Ritesh is asking, approximately how much time it takes one process?
Well, it just depends on the volume and the dimensions of the part, okay? Due to the fact that, for example, for SLM50, that is the 3D printer we use for precious metal, okay, gold and platinum. I was saying, due to the fact the platform is not a very large platform because it's around 70 millimeters diameter, okay? You can imagine that there is room for 5, 6, 7 very large rings, for example. I prefer to refer to this kind of very large and flashy geometries because it's what new SLM allowed to you to do. Okay. Well, I was saying to print 5, 6, 7 rings of this size, it takes about 4, 5 hours. Okay. At the end of the process, we are ready to take off the platform and remove supports and have 5 rings, very large rings ready. But for example, consider that 3D printer can work 24 hours a day and 7 days a week, okay? Because it's important to start the job and the process, for example, at the end of the day when you are leaving the company, and the 3D printer works overnight, and you find on the next morning you find your parts ready.
Okay.
Anyway,
thank you, Luigi.
It depends on volume and dimension, but because it could take 1 hour, 2 hours if the part is very small. It could take even more than 4 or 5 hours if the parts are quite large and the volume is high. Okay.
Okay, hope we answer Ritesh. Let's go to the next one. Thank you, Luigi. And let me try to say this name. Don't be angry on me if I wrong pronounce. So Tanantan. Okay, hi. Could you please throw some light on finishing of 3D jewelry? Will it be like regular cast jewelry?
Yes. The answer is yes. I mean, we mean that you have to consider that even if you find quite a rough, apparently rough surface on the pieces that we manage by 3D printing, okay, please consider that the material, the surface, below this external roughness is very, very homogeneous and allows to you to reach very nice and impressive results, okay, in the same time or even in a short time compared with traditional or direct casting, okay? So the answer is yes. Finishing times are more or less the same. We think, but we don't like to speak too much about this matter. I mean, we think that times, process times are even lower than compared with traditional casting production. Okay, due to this fact that I have just said, that the surface below under this external roughness is very, very impressive. Okay, and for example, because you don't need to solder anything, you don't need to assemble anything, because you find your hollow part that is ready to be polished and does not require any soldering phase. Okay, please consider how much time takes to assemble and solder, and you will probably accept my answer.
Okay, thank you very much, Luigi. We hope we answered. Anyhow, at the end of the webinar, every single question, then we will try via email to answer in deep and in more wide way. Then Vajizan is asking, can you talk about the possible types of defects occurring through 3D metal printing?
I would say general kind of defects, okay? It can happen that we find some residual porosity. It might depend on many aspects, many reasons, okay? Please consider that the management of the 3D printer, of the powder, okay, are quite complex. We became, let me say, a little bit expert regarding this matter. But as I told you, the management is quite complex, and something can go wrong, okay? But we are able to discover, for example, when we produce quite a large batch of objects, we often take the first, operate a kind of quality control, okay, random quality control on these parts. Anyway, something sometimes happens, but basically, we think that, as I told you before, we think that you might find probably less defects on these parts than compared with traditional casting. Just let me tell something. For example, a defect, but it's not a defect of the part. Sometimes happens that we are not able to grant the necessary supports projects, okay, and the parts collapse during the production. But this is not a defect. This is a problem that we face, and we do not speak about this problem with you, okay, because we will redo the part and okay, study a new support project in order to reach the end of the process.
Do you mind? Oh, sorry, finish.
Well, I do not consider this fact a defect, but please consider that probably we spoke quickly about this matter. Consider that semi-finished parts that we deliver to the customer come with a different kind of roughness, surface roughness, compared with traditional casting, and probably more close to direct casting. Well, this is not a defect, okay? But it's something that you have to face, and sometimes, or better, somewhere, not sometimes, because it's always somewhere, there are also some walls, okay, surface areas where that are the area that area of the surface of the part that are in contact with supports. Okay, this is not a defect. It's something that you have to face. Okay.
Do you mind if I add something, Luigi, about the defects?
Not at all, for sure,
No.
not at all.
Let's say if we say that in casting we can have a gas porosity due to investment reaction or metal evaporation. We can have shrinkage porosity due to the shrinking of the metal in the during the solidification and maybe the wrong feeder project. We can have oxide inclusion, or we can have investment inclusion. In case of metal printing, we can have only gas porosity, which is mainly due to the gas entrapped in the chamber in between every single particle of the powder. But in most of cases, it's just a reason of parameters, and you have to consider that once you are reprinting the same items and you had time to set up the parameters, then the consistency of metal printing is much higher than the consistency of casting. Many cases, our customer give us just one shot. So they send us a file, one piece, we have to print and reach the best result possible. And because if not, that since it's a new technology, even if it's still pretty new technology, then we risk that in the mind of our clients, there is the fact that also the technology has some defects together with the high roughness and so on. But in the truth is that even if you do casting, just one item, first time, all of you that you are doing casting every day, most of you, for sure, you know that it takes time to fix, the temperature, casting temperature, the proper alloy, flash temperature, the feeder system, and many other variables in casting. So the first time is not really always the time that you are really able to achieve the desired quality. So that's all. So next question to Andrew. How does pricing work for production? Is it volume based or per unit? Image, platinum, and titanium would cost the same besides the metal cost.
Which is the final part of the question, Damiano?
Image, platinum, and titanium.
Yeah.
With I suppose cost. I don't know the meaning, so maybe now I check in the meantime. Cost the same besides the metal costs. So the question is, the thing is, printing platinum and printing titanium cost the same, beside the metal cost, where platinum is more expensive.
Yeah.
So I repeat, how does pricing work for production? Is it volume based or per unit?
Well, I would say, I would answer this way, okay? We studied and prepared a particular algorithm, okay, to calculate prices. This algorithm works on our web page, where you can upload your file and see how much they cost, okay? Well, it works per unit, per volume. Well, the answer is prices are affected basically by the volume of the parts, and I would say also the number of the parts. This is quite a different matter, okay? But please consider that prices, we calculate prices in the same way of you, okay? By uploading the file on our website, because below the website works a complex algorithm to calculate platinum, titanium, gold prices according to the geometry of your parts, the volume of your parts, and the number of parts that you require. Okay. I didn't completely understand the end of the question, but
just confirm if titanium and platinum in volume cost the same money. Forget about cost of metal, but is platinum and titanium, Mage, the guy that Andrew
okay.
is giving
Well,
out the question.
the answer is no, okay, because we operate different 3D printing prices according to the metal that is required, okay. There's also a reason for that. The first one, for example, is that for titanium, we use a larger machine than SLM50, that is the small 3D printer, and we use a larger machine, as I told you, that costs much more than SLM50. And this is a first question. It's true that the platform of this larger machine is wider than the previous one. Anyway, it works in this way. There is different prices for different materials, okay? And you know that 3D printing is not a casting replacement. For technical reasons and from a technical point of view, probably also from, I would say, economical point of view. But this is another matter. To answer to you, I would say that this algorithm that I mentioned calculates prices according to volume, dimension, and number of parts.
Thank you, Luigi, and I hope Andrew will answer. Anyway, we will take care even to have a much complete answer in the next coming days. Shailesh is asking, what is the hardness of 18 karat gold?
18 karat gold, what color, I would say? Well, please,
maybe in general.
Well, consider that for yellow gold, the hardness is basically the same of the hardness coming from traditional investment casting process, okay? Quite the same. Rose gold and palladium white gold have also an option, okay? The service offers an option to decide for a lower hardness, okay? Probably that is, and the value is probably the same of casting or a little bit higher, and a higher value, okay? So in rose gold and palladium white gold, you can decide which option you prefer, okay? And there is a value similar to casting and a value higher, but this for rose and white, while yellow gold is basically the same of what coming from casting.
And if you not mind, in yellow gold between 135 to 160 Vickers, rose gold 170 to 180, and white gold almost the same. So you have to consider 5% higher, 5 to 10% higher than casting, due to the smaller grain size structure. But it's really something that the goldsmith is not able even to catch. And generally, yellow gold a little bit harder, or even rose gold is quite good, because as Luigi showed on mechanical properties, the alloy, you need much more force to break, and its elongation is even higher. So this is a good thing
it's
for metal. Yeah.
Appreciated.
Good. So Jimmy is asking, is the surface, I see the surface is granular. How you surface finish the pieces?
I'm not sure I understood.
I see the surface is granular.
Yeah.
So how you surface finish the pieces? So since it is rough, how you finish the pieces?
Well, we do not finish the parts.
Okay, but
Probably.
generally your customer.
Well, they finish. Okay. Personally, as a service, we deliver and ship just semi-finished. Okay, so we do not finish the part inside. Our customer, our clients operate basically in the same way of pieces coming from casting. Okay, probably what changed is about titanium. Titanium is a little bit harder and is a material a little bit more tough to be polished, but by practice you are able to achieve the same perfect results of pieces coming from casting.
Okay, thank you, Luigi. And let me go to the next question. So another guy is asking, hi there. Okay, I would like to know if the surface of the metal is suitable for polishing, setting gemstones and soldering afterwards, if we need to assemble part of different metal, for instance. Do you want me to read again? Because
No,
maybe I didn't.
just the final part of the question.
Okay. Suitable for polishing, setting
Yeah.
gemstone and soldering afterwards.
For sure.
If we need to assemble part of different metal, for instance. So.
Well, to assemble part of different metals is something that happens probably out of here, so needs to be understood, okay? But I would like to answer, yes, it's possible for sure to clean surfaces, to set stones, and to solder and soldering if you require it. Absolutely possible, as it is in traditional casting process. For
the metal,
pieces coming from traditional casting process.
The metal is the same. You have to consider like casting, so it's not that it's reacting in different way when you put the torch or the laser or that things, because it's melted metal. It's not sintered, so forget about sintering. And the last part, let me answer Luigi about assembling part of different metal. Of course, if you have white gold and then you want to put your casting items and assemble of rose gold or yellow gold outside here, of course it is possible. As you do in casting, then you can do with parts that we print.
Yeah.
Another question, Ravi is asking, what is time of products output? Can we have cut? Okay. What is the time of product output? I think that is what you answered before, right?
Well, I repeat because it's an important matter. For example, if you need to have in your hands, okay, you are in the United States instead of India or whatever, and you need to have in your hands your first 5 prototypes of rings, okay, I would say that SLM is a very fast process, because from the day we receive the file from you, probably we are able to ship and put this part in your hands within 4-5 days, something like that, okay? Shipping included. So this is the answer that I'd like to bring to you, to give you, because I consider the process as a fast process, and in a few days you have got the parts in your hands. Okay, I mean, if you need a first prototype, one-off, small batches. If you need 100 rings, or it will take about 1 week, something like that. But don't worry about timing, okay? Because SLM performs from this point of view.
Okay, thank you, Luigi. Then there is some other question that Ravi is giving, but I think that you have to answer in private because it's something commercial and make.
Okay, write to me directly, and I
It's
will answer.
It's written
Okay.
for a catalog and that things.
Perfect.
Naren is asking, is it possible to make in pure gold?
I would say not. We use well, we operate so far with 18 karat gold. I'm not so expert, but I think that the same problems and troubles that you might face in casting pure gold, you would face in 3D printing pure gold.
But if someone is doing casting pure gold, can he use metal printing for printing pure gold? I will say yes, very much. I mean, there is no limit.
Well, probably there are no limits. It's something that we do not provide so far.
No, we do not provide, but it's possible.
Theoretically, probably it's possible, yeah.
Our service bureau, of course, is not going to commercial. It depends. If the order is quite big, even we consider pure gold printing, but in general, we have not these on list of our materials. But technically speaking, selective laser melting has no limits on metals. Let's say that there are few limits or a bit tough in silver, because silver is possible to do, but it's not as easy as it is platinum, titanium, stainless steel, gold, and so on.
Okay.
David is asking, would you agree that additive manufacturing or selective laser melting, as we want to talk, is more suitable for platinum than casting?
Yes, we do. As we told you many times during the presentation, or better, as a concept that we try to focus in your mind, it's not something that we believe or we think, okay? It's something that is proved, okay? Platinum is absolutely matched with the SLM, and probably is much more easy to handle platinum by SLM than handling it by casting. But the answer is yes. Yes, platinum is absolutely the best performing material and absolutely suitable for SLM. And so SLM is suitable for platinum.
Okay, Andrew is asking, can you mix or blend precious with no precious materials in the same production run?
No. No, we do not blend non-precious material with precious material. No, it's not possible. Or possible or not possible is something that we do not need to do, and something that is not required. But I would say no. So far, it's not possible to blend precious metal with other materials. Okay.
Okay. Jimmy is asking, what is the average percentage loss, say a 4-gram ring coming out of the printer? What will be the final weight after finishing?
4-gram virtual weight.
You have 4 grams after printing. So which is the loss during polishing?
Well,
during number, if you don't remember.
There are no difference, I will say.
Okay. All.
There is no an higher loss polishing pieces coming from 3D printing. Not at all. It's the same of polishing another the same objects coming from traditional casting. So no differences.
But in terms of really weight, is in the range of 4 gram. If I well remember, there is a 0.6, 0.7 gram. Then is depending really very much on the surface in where you have this 4 gram of your ring. The higher the surface, the higher the loss. But this is the amount. But really, I hope that you wanted to compare with your casting, and you have not to be worried. It's already proved in another webinar. We were talking about platinum, for example, and different than what we expected, or even what the goldsmith expected. The loss, it was exactly comparable. So no more. Why? Of course, it's more rough. But then, as Luigi said several times, below this roughness is very solid, the material, very consistent.
Very impressive.
Yeah. On the other side, casting, sometimes you have to really grind it more and more. You have to rework, because then there are some porosity. That it depends, of course, if you, and especially if you are going to print something that, or cast something that is 10, 15 grams, 18 grams, so something a bit heavy, then it's tough. That's why the loss percentage is not very much.
Damiano, let me not introduce, just spend very few words. From weight point of view, there are many others very interesting topics, okay?
Exactly, yeah.
Regarding SLM. So I understand your question, and I hope me and Damiano were able to answer. All of you, please consider that from weight point of view, there are a lot of very interesting topics and issues, okay? For example, for a very large part, okay, with a very important dimension, please consider that you can work with a very thin wall and maintain a very low weight. This is a very important and interesting matter regarding weight, okay?
Okay, thank you, Luigi, and I hope we answered. Another guy is asking, can we print one single piece with 2 different metals, for example?
I would say no. It was a kind of test that we operated, okay, but the answer is no.
Yeah, but they are asking if possible, not if you are doing.
Well, but
it's possible, yes.
Is possible from a theoretical point of view. Is possible, okay, but
does
you have.
Work? Does it work?
Does it work? I don't know. I don't know.
No,
because
does it work? Is it convenient? Not really.
Probably no. Okay, because well, in our organization so far, you would have to. How would I say? To print, for example, half of a ring, and then to remove that half of a ring. And how do you work on? Or do you move the parts to another machine, or do you change the powder? Quite complex. I would say not so far regarding our service, but probably other service too. Anyway, no.
And then in general, it's very flat. So and then you have a flat connection. So you cannot do any strange design. You can connect to metal. We tried, and even someone else is trying. But we do not see. It seems like a useless technical exercise.
Well, but Damiano, it's important also to understand if we understood the question.
Yeah.
This is what I mean. As a semi-finished part, okay, complete and close and solder it, this is not possible. But at our side, at this level, if you mean I print a yellow gold part, and then I print a different rose gold part, and I receive them separated,
No, I didn't ask you. In the
Okay,
same metal.
by the process, no, not
Single
by the
piece with
process.
two different metal, for
No,
example. Same
not by the
process.
process, not by the
Okay.
process.
It is an expensive. Another guy is asking: is it an expensive process compared with traditional casting?
Well, the answer is quite complex. I would like to say that it's not a cheaper technology, for sure. It's not a cheaper technology compared with traditional casting. It's not a replacing technology, as I told you before, replacing of a casting, I mean. It allows different projects from casting, different thinking, okay. I think that when a geometry, an idea is suitable for 3D printing, much more than for casting, okay, you might try to get it by 3D printing, SLM, and if you are able to do the same part by casting, you would have to consider all the phases. Soldering, for example, time consuming by assembly different parts. If you imagine a large hollow part. For sure, if you imagine a traditional wedding ring, well, wedding ring is another matter, and we could also speak about this matter, but for a solitaire, for example, probably there are no reason to go through 3D printing and SLM to produce a traditional solitary ring, okay, probably.
But we were saying something opposite, Luigi. Then I mean, if you compare, if you make the industrial cost comparison, not the process, sorry, not the single phase comparison,
Yeah.
which the comparison of printing and comparison of traditional casting. But if you make an industrial comparison, in that case, so we have an example of bridal collection where in 12 models, 8 were cheaper on metal printing. They were very simple. So this is the tough things to answer this question. In general, if the piece is suitable for printing, the bigger it is, because then in industrial cost, you should consider also gold, because at the end, you cast something that where the weight is 15 grams, but the question is, do you need really on 15 grams, or 14 will be fine anyway? And
or
that
even lower.
Even lower, but let's say just 1 gram less. And
Yeah.
this $50 of 1 gram of pure gold, even of course it's 18 karat, so let's say $40. Do we consider in the industrial cost? So we should. That's why it depends. If you want to get the same, exactly the same item, and you do not take any advantage of on metal printing or taking the strength, so it's like to have a trip by car or by plane. If you don't care to take something like 2 days going by car or 1 hour going by airplane, if you do not use that remaining 19 hours to do something that is important for you, so why not go by car? So I hope we answer. Ritesh is asking, do we have, I think that he will want to say, do you have product in India for demonstration for physical view? Chintan has some products down there.
We have got the dealer, a very important and performing dealer in India, so no problem to show you some samples, okay? Not at all.
Okay.
And probably Chintan, our dealer so far, has got also something to show to you. Anyway, no problem to show to you something.
Alessio is asking, hi, could I know what is the difference in cost between this technology and traditional one? So
it's quite the same answer that we gave previously.
Okay, so because we have to speed up. Gani is asking whether it is possible to 3D print studded jewelry with diamonds. Diamond will be positioned during interim halt, and then it will be continued by 3D printing as earlier.
Okay, I think I understood the question, but the answer is no. Okay, we do not operate. Tell me, Damiano.
No,
Do you
but
agree?
I mean, it's something that we don't do, but the technology shows that others
Yes,
are
it's
doing.
possible. Anyway, it's possible to put a stone inside a kind of cage, okay, but this is a fact. Another matter is to fix a stone as it is normally in a different ring. Anyway, quite a theoretical question, a theoretical answer.
I mean, but there is someone that is, but the diamond has to be like inside a jail, not set like a setting on stones.
Yes. So
that one is possible.
It's possible, and we.
But we don't do.
Yes, we don't do. Okay, but we did. We try to put some stones inside this kind of cage. Okay, you can stop the machine, put the stones, and then restart the machine. At the end, you will have a cage with the stone or what else inside.
Okay, thank you, Luigi. Another question from Gani again. What is the strength to weight ratio comparison between traditional casting and direct reprinting for 18-karat yellow gold? I don't understand the question.
At the beginning, the strength of?
The weight ratio.
Weight
ratio comparison between traditional casting and direct 3D printing of, but I don't understand the question.
Well, also because it's quite an articulate question that requires.
Okay. Maybe we will contact you directly, and then
because it requires a wide answer, a very wide answer.
Okay, Ritesh is asking, the cut we get done, are they different for this type of metal printer, as we have to keep extra pounds thickness considering shrinkage?
Well, you have to consider that SLM has got no shrinkage, okay? Conversely, provides a little increase of the dimension, very, very little, okay? But you don't have any shrinkage operating by SLM. So you have to consider this fact also regarding your file and your dimension adjusting, okay?
Okay, thank you very much. Alessio is asking, what is the size of the grain? I mean, the alloys. I think the powder, I suppose.
Well, granulometry is a wide matter and belongs to our know-how, okay? So it's not so important referring about granulometry. Please consider that granulometry is not such a deep secret, okay? Quite all the printers working with metals use a kind of standard granulometry, but is something that is useless regarding this kind of matter, okay, this kind of presentation. And for example, we investigated different and alternative granulometry to understand what happened, for example, from resolution point of view. And this is part of our previous investigation.
Thank you, Luigi. I hope Alessio we answered. Sanjay is asking, are you saying after printing it's a zero loss to get final product? It is connected to what we said before. No.
No zero loss.
0.6, 0.8 gram on this 4-gram ring.
So no zero loss in polishing for sure is not possible. but the same kind of loss that you can consider for pieces coming from traditional or direct casting.
Okay, thank you, Luigi. Jim is asking, do you provide powders and 3D printers or only provide service?
We just provide the service. 3D printer and powder was a business model, a previous business model of many years ago, but so far we just sell the service.
Thank you. Sanjay is asking, can we do two-tone castings? How many pieces? Two-tone castings.
Two-tone casting.
Yeah, two-color, I think, but casting.
Ah.
And how many pieces at one go we can cast? So let's say the first question you already answered, as I understand. So two-color.
No.
Let's say theoretically possible, but we do not see advantages.
Yeah.
Second, how many pieces at one go we can cast? From 1 to 100 on one platform. It depends on size. On one job, how many pieces can we?
Well, it depends on the dimensions of the part. Yeah. Okay, volume and dimensions. Precious metal platform is not such a wide platform, but in any case, around 70 millimeters. So it can accept from 5, 6 very large rings to 10, 15 smaller rings. Titanium is another question. Is another story because the platform is wider.
Sanjay is asking, can we do hollow jewelry pieces?
For sure.
Okay, good.
For sure. This is one of the strengths of SLM. Hollow, large, closed, complete, without soldering.
Okay, we have the last question, Luigi, so you have to answer at your best. Is there any general guidelines where one can easily decide that metal printing will be better than casting? So some parts can be printed and some can be casted and mixed together to get advantage of both process.
But please help me because
So general guidelines to decide when metal printing is better than casting.
Okay, yeah. Yes, there are general guidelines for sure. Okay, as I told you before, when we receive from our customers different files, we start evaluating if these geometries are suitable for 3D printing, for SLM or not. Okay, or if it's better to say to the customer, okay, we would say that these geometries are more suitable for traditional or direct casting instead of SLM. What I want to say is that sometimes happens that we receive some particular geometries, okay, that were born lucky from this point of view because they are perfectly ready to go through SLM. But if this happens, okay, all we are happy. We are able also to help and to drive the customer in the right direction, okay, with a small correction regarding their ideas, their file, okay. And we noticed that when you start approach SLM and you obtain your first parts, later on we noticed that customer start to go in the right direction by themselves, okay, because they change their idea, they change their point of view regarding design, they understand what is possible to do by SLM, and they start to give us much more suitable design, geometries, and file, okay? So there is a kind of upgrading of development also in a customer point of view. Anyway, sometimes it happens that we receive these lucky geometries. General guidelines refer to, for example, all objects, large all objects closed without soldering, and this is an information. Basically, we prefer to 3D print large, wide, and flat surfaces, okay? Not because it's not possible to 3D print different surfaces from these, but because we try to understand what happened after 3D printing and when the parts are in the hands of the customer for the polishing phases, okay? So SLM happily marries these geometries, these wide surfaces with not a lot of cavities, details, not because, as I told you, it's not able to give you back these details after 3D printing, but because it might be complex to finish these very complex and detailed surfaces. What else? Wide surfaces, all of objects. Probably, for sure, I'm forgetting something so far, but it's important to recognize SLM advantages and to start to dialogue with us, to share some geometries in order to start a process, okay? A process of growth among we and you together.
So we reached the end of the webinar. Talks longer for the question and answer, more than the
webinar itself.
Yeah, but this makes sense, and we love very much, because then it's a way for everyone to, you know, to interact each other, and then it's always a starting point to think about something, and to even to add some more information than the one that we were in discussing or presenting during the presentation. So thank you very much. Thank you very much, Luigi, and all of you. And we will contact you directly in case we were not able to answer your question. And hope that soon we will have another interesting webinar to discuss some latest achievement about metal printing. So
well,
yes, sorry, Luigi.
No, Damiano. You know that we did not mention something quite important, but I refer to latest development in titanium. But there will be, yes, this is what you mean. Okay, this is exactly what you mean. Okay. So there will be a next occasion. Yeah, okay. Correct.
There is also that we have a new achievement that after printing you have not to polish, you go straight to the shop. No, okay, I'm just joking. This is not still possible, but you know, it will be very nice to go in this way, to have this kind of chance. But anyway, we are working every day, and we love to share, and we believe that is an important time to try to know each other, from which is the result of our investigation. Today, we intentionally wanted to stay on the top, not go deep under the surface, and to talk about really something in general without any evidence about the why and what we were saying. So have a nice day ahead for the friends from West. Good evening for people in Europe, and good night for everyone who was following from Asia. So thank you very much.
Yes, thank you for your attention.
See you soon.
Thank you for your attention. Bye bye.
Bye bye.
Ciao.
Ciao.